we are going to do today linked list. Linked list. Basic idea about the linked list I had given in past classes. But we will be doing it today. Linked list. What is linked list? I had already informed you, means explained about it. We have different nodes. What is the disadvantage of arrays? You cannot insert or delete directly any element from the arrays if you want to delete in between. Means suppose that you have 10 elements in the array and you want to delete 6 elements, or you want to insert at 5th place. You cannot do it directly. It takes more time. And array size should also allow you. Then only you can do that. But in the linked list, this is the disadvantage of array, and that is why in the data structure you need linked list, where freely you can add or delete any element as per your choice and as per your place wherever you want to insert or delete. So for that, what two things we need? One, we are talking about currently singly linked list. In the singly linked list, you have a node, and in that node, two parts are there. Two parts are there. First part is called the place where you store data, and second part is the next pointer. Okay, second part is the next pointer, or you can say link, or you can write next pointer. Now if I am saying link or next pointer, means it will connect to the next node. So how linked list will look like? This is a node. So firstly you should know how to create these nodes. Firstly you should know how to create these nodes, and then you can do all these things. So how a linked list will look like? You will have different nodes, and this link next pointer will be connecting to next node, then next node, then next node. So it will look like this. So suppose that you have 4 elements, so you have done this. So here anything you can write, X, Y, Z, A, as per your choice. You can, as per your choice, you can store the data. Or if you want to store integer, you can write any number as per your choice. Suppose that 10, 30, 25. Okay. So in the node, two things will be there. One is data part, and one is next pointer, that is link of the next node. Now, how many data is? 4 data are there. Four nodes are there. Yeah. This link place next pointer will contain the address of next node. Next node. That's how you will link it. That is the advantage of the linked list. Now, what all operations we can perform in this? What all operations we can perform in this? First, you can insert at any place. Hmm? Then what can you do? You can delete the node from any place. Hmm? And you can traverse it. Traversal. You can traverse. Traverse means from first node till last node you can go. Now, insertion and deletion is the main part. Suppose that you had this linked list. From how many places you can delete? What could be the condition? If you want to insert, what will be the condition? At how many places you can insert or at how many places you can delete? Actually, three places. Three places. I will tell you which three. Beginning, hmm? Beginning, that is first node, hmm? First node or first place, first place, hmm? In the beginning means you want to insert here. Before 10 you want to insert 2. So as a first node you want to insert, hmm? Or we'll do all the cases in between two nodes, in between 10:30, in between 30:20, in between 20:05. So for that there will be another condition, hmm? Or third condition could be end, means last node. So these are the three conditions. Same three could be in deletion as well or not. Beginning, in between, and last. These three will be the conditions. Hmm? Now let's do it here. Let's do it here. You will understand with this. Suppose that you have the three values. Hmm? Here suppose that you have 10, 30 and 20. At last, if nothing is there, then here what will you store? Null. Next address is null. So here you can store null, means your linked list is ending there. Now, suppose that you want to insert at first place. You want to insert at first place. So what will you do? How will you insert at first place? You will create a node. You will create a node, new node, hmm? And data whatever you want you store, and the address of this you will be giving to this node. Yes. So what is the address of the first node? Sorry? Address of the first node. Yeah. Address of no, this node will be there at some place in the memory. No, I'm asking like for the first node. What is the address of the first node? Where is it? In the linked list, it is given the for the first node address of the second node is given. Yes. So in your list, whatever you are asking, in your list, eh, the first node with the name of the first node. it will become next. We will come to that point. Don't worry, we will be doing everything, whatever is your doubt. Now, if you want to insert in between 10 and 30, then easily what will you do? Whatever you had stored, you will change it, the address this, isn't it? And this, you will give the address this. Now, if you want to store at last, then what will you do? From null, you will change it to here. So this is in the beginning if you want to insert. This is if you want to insert in between, and this is when you want to insert at last. Okay? This diagram I am just explaining so that you, whenever we will be writing the program, you should have this visualization that we are doing this. Otherwise, later on you will be confused why we are considering this first node, why we are considering this last node, why we are considering this next node, and how we are going to previous, next, and all those things. Okay? So these are the three cases clear. If you have the nodes linked list, so whenever you have to insert in the beginning, what you will have to do, how you will be doing, that will be writing in the program. But what you have to do, you understood? In between, if you have to insert, what will you do? Understood? At last, if you have to do, what you will do? You understood? Now let's come for deletion. So this is for insertion condition. This is your insertion. Now let's come for the deletion. So what will you do? If you have 3 nodes, again here those 3 conditions, beginning, in between, and last. Beginning, in between, and last. So if you want to delete this first node, what will you do? So till now in your list, this was the first node. Just change the position of the first node. Make this as a first node. Second one. And free this first node. Suppose that, like in the class, suppose that these 4 students are there. First row, 1, 2, 3, 4. 4 students are there. And somebody is not focusing in the class. Then teacher is saying, okay, I don't consider you in the class, you can go out. I will start from here, first, second, third. Once you are coming back, then you sit here, then you will be the first one. Till you are going, we will start from here. This row will start from the second place, not from the first place. Similarly. Now, let's come for deletion of the second row. Second element means in between. So what will you do? The address here, earlier you had stored the second place address. What will you do? You will store this. So once you will store this node will not be connected now in with any node. So that will not be in the loop. Similarly, if you want to delete the last node, then what will you do? Second last node where you are storing the address means here you will store null. Then this will automatically be free. Understood? So now let's write the program. With the program you will understand in more better way. So let's write the program, and I will write the full program so that you should not be confused later on. I had already told you, please revise malloc and calloc. These are the two dynamic memory allocations. In last class I had told you, please revise it before coming in the class. Anyway, I will be writing it here. So there are fixed syntax for that. Okay. So we'll start with include stdio.h. Include conio.h. Then one more header file you include here. Include alloc.h, where we will be using calloc and malloc. Okay. Then create some functions prototype. Okay. So for starting the linked list, firstly you will have to create a node or not, and then only you can keep adding those nodes wherever you want, or you can keep deleting those nodes wherever you want. But firstly you will have to create that node. So let's create one function with void create. Void create. This is a function where we will be defining how to create the node. Then void insert. Here we will, using this function, we will be defining how to insert with all the cases. Then create one more function for delete, delete. And then finally what you will have to do? You will have to display all those things. So write void display, where we will be giving the option to display whatever you have written. So this is all about the functions which we are going to write. Okay. Now, whenever you are creating a node, so which two parts are there? Firstly, you will create a node. Means you will have to create this structure. You will have to create this structure, and within this structure, one more structure you will have to create for the link, because you have to create two parts. Please be careful. So within this structure, you will be creating one more structure for the link. So now you have two parts finally. So how do you create the structure? Hope you know the structure syntax. So we start with struct. We start with struct, And suppose that you are creating a node. So you are writing struct node. Struct node. Now, so in this struct node, which two parts are there? One is this data, isn't it? So what will you write? Int data. And then within this structure, this is you are creating for the link or not? This is link. One more structure for the link. So use this thing. So write struct node within this structure only. You will create one more structure variable struct node pointer with link. Okay. And then semicolon. So hope you understood how we are creating it. One structure, and within that one more structure with same structure variable. Okay. So this will be your structure through which we are going to write the program. Now, everyone has noted down this? Any confusion? Okay. So we'll go to the next. After this, you will have to define some structure variable. Okay. Now, let's define the structure variable. So struct node this is the way to define the structure variable. Now we will take some variables which I was just talking. First node, last node, next node, previous node, and null pointer. All these we will be making null. Many things will be making null, and then we will be taking one current pointer as well. At which current node we are, because you will have to check it, no? Whenever you are performing the operations, you should know what is the current node, what is the previous node of that, what is the next node, what is the first node in your list, what is the last node in your list. So all these variables we will be defining. So struct node, let's write first pointer first equal to restricted first equal to null. So right now nothing is there in that, comma, next, or let's make it last. Now make it null. Pointer, comma, previous pointer, comma, current pointer, and semicolon. So you have defined the structure variables now. You have defined the structure variables now. Now we will be writing each functions. So first function which we had defined was create. Firstly you will have to create it and then only you can insert. So how will you create the node? So you write void create, and you will have to make one current node. So just see here, I don't know whether you have used previously calloc malloc functions or not. You will write cur equal to this cur, you have already defined it here. Hmm? So means current equal to, and this is the syntax. Struct node star malloc 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 size of sizof struct node size of size of I'll just write it here, just wait. What will you write? Size of struct size of, and then this is the starting bracket, struct space node, then this, and then this bracket, close it, and then you will have semicolon. You will have semicolon. Okay. So what you are writing? Hope this is visible to everyone. Current equal to struct node star malloc size of struct node. Now this struct node, the structure which you had defined. Okay. Malloc is used to allocate the memory for this node dynamically. Okay. So this syntax you remember, in this format only you will be writing it. Just malloc syntax if you have any confusion. That's why I had told you please revise these two things. So everyone has noted down this? Should I go to next step? Now we will insert the data in the first node. We will insert the data in the first node. So we will write printf enter the data. So how many parts are there? Two parts in the struct node. First part was data and second part was link, address of the next pointer. So firstly we are entering the data in the first part. Okay. Yeah, any question? Yes. We have not closed this is, you started with current node. You have assigned a memory allocation, means you have allocated a memory for a new node, current node. And now what you are going to do? You are entering the data in that. Means you had this part. So currently you have created a current node. Now you are inserting the data here. Okay. So enter the data. and then you write scanf. If you have to take it from user, you know you will be writing scanf %d, comma, and then end %, where actually you have to insert the data in the current node, and which place, two places are there, data part. So what will you write? End %cur current arrow data, semicolon. Okay, so current data. Okay, any confusion till now here? Now, since this is the first node, so what will be the link of this current node? Even you don't know whether it's first node or last node, this is the just one node you have created, isn't it? So what will you write? Current link equal to null, because there is nothing. You are not giving any other node link. Okay? Now, if current link equal to null, it means what? You have only one node. So that node will be the first node as well, and that node will be the last node as well. Isn't it? If you have only one node, so this will be null or not? This will be null. And this is the only one node you have. This will be the first and this will be the last as well. So what will you write here? First equal to current and last equal to, means whatever the node you have created, that is first and last, everything is there. If only one student is there in the class, so who came first, who came last in the class? That only one student. And then close the bracket. Means, so this is your create function. Okay? So what did you do? You allotted one memory for your node with the current node, and then in the current node you have inserted the data as per your choice, and then since there is only one node in the list, that will be first, that will be last, and the link will be null. Okay? Everyone has noted down? Online students, any problem?
No, sir.
Okay, good. So now we'll go to the next function which we have to create. We have to write create with completed. Now you have to insert. Unless you will not insert, how will you be showing your list? So next function we will be writing void insert. void insert. So define some variable here, int position, POS, we are taking a variable, and one counter we are taking C equal to 1. Why do you need the position and counter? You will have to take from the user at which position you want to insert the node, isn't it? Whether first position, second position, third position, fourth position, fifth position, sixth position, everything you will have to take it, no? From the user. And then counter you are taking to count it which position you have reached till now. Okay? So again, what will you do? You will take same thing, that current equal to struct node star malloc size of, there is no space in size of, struct node okay. So in this you should not have any confusion how you are writing. Then again you will be entering the data, which data you want to insert in that node. So data you can enter directly, but while entering the address link, you need to know the position, isn't it? At which position this address should go. So let's enter the data. So printf enter the data, scanf %d and percent current data. Okay. So data you have entered. Now what you do, you take the position from the user. At which position you want to enter the data. Means at which position you want to place this node. So till here everybody is noted down. So we'll go to the next slide. Now what you do, printf enter the position. Enter the position. Scanf you have already defined one variable for this, and percent position. Now you will have to check the conditions whether you want to insert in the beginning, in between, or last. So what will be the first condition? What will be the first condition? If you want to insert at first position and first is not equal to null, means there is something at first position, isn't it? So what condition you will check? If I will write this condition in the some other color so that you should be able to identify it easily. If whatever the position you are entering, whatever the position you are entering is equal to, how do we write? One means first position you want to enter, and first is not equal to null, means there is already something at first. First not equal to null. So one more bracket here, one more bracket here. Then what will you do? Then this will be the answer for your question, Munej, which you are asking. That's what you are asking, no? So what will you do? You have current node which you have created right now, and you have something already at first. So what you will have to do? Current link will go where? To the first. So what will you write? Current link equal to first. Okay? Current link equal to first. Data you have already entered. Now, I'll just give one example here. With that, you will understand what I am saying. See, suppose that you had this already. So this was your first. This was your first. And what you are inserting, this is. So current link equal to what you are doing? First. That's what did you do? You did, no? So now which one will become first now? First will be what now? First will be current. So first will be current as well. So what should you write it here? Because you will have to define which one is the first in your list, updated first. So first will be new, first will be what? Current. So what will you write? First equal to current. Okay? Any confusion in this? So this is your first condition. Now, if your position is not 1, means you will go to else. else, I'm just writing one condition, else next equal to first, and in this only you use one condition while C is less than position. Means now what you have to check, if position is 2, 3, 4, 5, 6, C will keep increasing, counter you will have to go now where you are going next. So you will keep going next, 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 next. So while C is less than position, then what will you write? Previous equal to next. Means you will keep going to the next node, next node, next node, and next equal to previous link. And every time you will keep writing C plus plus to increase the counter C. Okay? And then you will close this bracket. One more thing you will do. If previous node, you are checking the previous as well. You are going to next, 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 next. Huh? And what happened? See, previous equal to next. Previous equal to next, here we are writing. Means you keep going till this condition is not satisfied. Till this condition is not satisfied. Actually here we should have not written position full. Which variable you had defined? POS. So actually we wrote full form. Here it should be POS only. Because we defined position as a POS variable. So if you keep going, suppose that you have only 5 nodes. You have only 5 nodes. So till which position you can insert? From position 1 till position 6. From position 1 till position 6. Because if you will go position 6, still you will have previous equal to null. Isn't it? And if you are getting previous equal to null, it means you are inserting at last node as a last node. But if position is like somebody is entering 7 or 8 and you have only 5 node. You have only 5 node and somebody is entering 7 or 8. Then previous will be null or not? No. Because after 5th, 6th position you can insert. If you are going to 7th position, means counter C is becoming 7, will you have any previous node? No. So in that case, what will you write? In that case, what will you write? If previous means PREV equal to null. means there is no previous node. Then what will happen? Printf invalid position. Invalid position, isn't it? Else 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 means if you are inserting as a last node, else starting bracket current link equal to previous link, whatever I'm writing it here you can directly write in the lab and run it. If you have any confusion you can ask in the lab. Previous current link equal to previous link. Okay, and now previous link will become current. So this is the function which you will have to write for all three positions for current. Okay, hope everybody is noted down. Now we'll write the function for the delete. I'll be little bit faster now because I want to finish this program. Okay, and still if you will have any confusion we can always discuss in the lab as well. Okay, so don't worry. So let's write the function for the delete. So void delete. Now don't think I'm not writing at last e in the delete because like this I had defined in the beginning, if you will see, and this is user defined function, so you can write as per your choice. Here again you need position and counter, so define int position and c equal to 1. I'll be a little bit faster now. So printf the position. Here you don't have to enter the data, isn't it? You have to just check the position and delete it. And link only you have to shift it from one node to another node, or previous node to next or current node, or previous node make it null, or or first node make it null, first node link make it null, and next node become first node. So these are the things which we will be doing. So printf, you will be directly taking the position from the user, enter the position which you want to delete, enter the position which you want to delete, and then scanf %d and % position. Okay, Now, after this, suppose that you want to delete it. You want to delete it and you don't have any node to delete. You are key, you have 5 node and you have deleted everything and now there is nothing left. This can be one condition or not. If there is no node left in your linked list. So you will have to check for the list is empty or not. So how will you check? If first equal to null, isn't it? If first is null, then printf list is empty. Else, if now, if you have only one node and position is 1, this can be the condition or not. You have only one node and that also you want to delete. So position is 1 and first of link equal to null. Means there is no further node left. Only one node you have. Else if position is 1 and first of link equal to null, then what will you do? Printf deleted element is